Savin Goyal, co-founder and CTO at Outerbounds. Welcome to the Data Exchange podcast, and great to finally meet.
Yeah, thanks, Ben. Thanks for having me.
So you were previously a software engineer at Netflix, where you were instrumental in building and releasing Metaflow, which is a Python framework used inside Netflix, mainly by data scientists. So first of all, let's talk about Metaflow. So describe how Metaflow, what was the origin story of Metaflow inside Netflix?
Yeah, so let's think about sort of like the year 2017. And so me and my co-founder at Outerbounds, Wille, both of us, we were at Netflix, and we were part of the sort of like newly instituted team, machine learning infrastructure team, and we were tasked with sort of like figuring out like, okay, what is sort of like the best of the breed infrastructure that we can provide to our data scientists inside at Netflix. And before sort of like I talk about sort of like the infrastructure.
And what was Savin? So what was the target? So the target persona is data scientists. So these are people who use Python and notebooks.
So the target audience would be data scientists, and these are people using Python or R within, say, a notebook, maybe within sort of like their favorite editor, using all sorts of different machine learning techniques focused on, say, like on one end of the spectrum, Netflix recommendations, on the other end, like, hey, how should Netflix allocate $15 billion of content budget to identify sort of like the best movie and TV show that people would want to stream.
So immediately, to me, what jumps out is, one, they use Python and R, so there's certain ecosystem libraries they're attached to and love.
Yeah.
But then they're working on Netflix, which means scale. So hard for typical Python and R users to do that, right? So
exactly. And then each of these individuals, they're also highly skilled in machine learning, usually have advanced degrees in statistics, economics, and so on and so forth. So they're also strongly opinionated around like what kind of frameworks, what kind of libraries do they want to use. So that also sort of like adds.
We want everything.
So we want everything. Exactly. And now the question is that, okay, like if you're sort of like catering to that sort of diversity, how do you essentially ensure that meaningful progress can be made? And also there's a lot that goes into researching a business problem, converting that into a mathematical model, training a machine learning model, and deploying that into production. And now if you're looking at sort of like this much.
So Savin, circa 2017, when you guys were starting to think about this, was deep learning already kind of, we must support deep learning?
Not really.
Not really. Okay.
Not really. I mean, Netflix has always sort of like, stuck to the adage that, better quality data will result in better quality models. So that was the focus in and out. But then, of course, Netflix also operates at the bleeding edge of ML. So there were many areas where we were using deep learning. But I wouldn't say that, like deep learning was the most popular choice.
But was it part of the requirements for what you were going to build?
So in many ways, like for us, the requirements were more like, machine learning universe is very fast moving. So how can we make sure that, we're not sort of like making bets that would sort of like hinder our progress, say, like 2 years further or 4 years further down the line. So for us, the goal was that today it's sort of like, deep learning that's like super popular. Tomorrow there could be sort of like a new way of doing machine learning. And how can we make sure that we are providing that freedom of choice to our data scientists and not really sort of like encumbering on that. And from our point of view, the way we sort of like look at this problem is that, as sort of like a data scientist at Netflix, you were engaged in data science related issues like, okay, like where am I getting my data from? What framework should I be using? Is deep learning the appropriate choice or not? And then there were a lot of engineering specific problems that, okay, like now I need to use an instance with GPUs. How do I get access to it? How do I launch my compute in the cloud? How do I move data around? How do I think about reproducibility, experiment tracking, versioning, model management?
But the entire, so what you wanted to do with Metaflow is support that entire pipeline from some sort of data prep, feature engineering, all the way to modeling, experiment tracking and management, maybe version control, right? So,
Yep.
and then some QA testing, and then deploy.
Exactly.
So but let me ask you this: is it true that so if I'm a data scientist at Netflix, I'm allowed to go all the way to production?
Yes.
Okay.
Yes. I mean, that's you're not only allowed, that's the expectation in many ways. And if you look at it, right, like the universe that we were sort of like operating in was we had sort of like data scientists as part of sort of like, teams. And then we had machine learning engineers and software engineers. And now if you sort of like have data scientists who have no control over what model gets deployed in production, what even productionizing a model, the ability to rapidly iterate on models, that gets rapidly hindered. And for us, that was the entire value proposition, right? Like there are certain things that data scientists want to be in control of, namely how they want to do machine learning, what are the techniques they want to use. And then there are these engineering concerns that, like honestly, a lot of data scientists would want other folks to sort of like just take care of those. And our focus was, even though our team's name was machine learning infrastructure, we did less of machine learning and more of infrastructure to sort of like just in many ways abstract out all those engineering concerns away from them, so that then they could just focus 100% of their time on ML related activities.
So fast forward to when you left Netflix.
Mm-hmm.
So what was the functionality of Metaflow at that point? And and how widely used was it at that point?
Sure. Yeah. All of Netflix engineering teams, data science teams were using Metaflow. That means like hundreds of data scientists using it day in and day out. It also sort of like resulted in acceleration of productivity. So before Metaflow, it would take sort of like a team of data scientists, many weeks, many months to sort of like even reliably train a model, let alone sort of like, consider moving it to production. And now we were in a universe where people could sort of like research, prototype a model, put that into production multiple times a day, all by themselves. We were also able to sort of like move away from that ideology where, you may have multiple data scientists in a team, but then each data scientist is still sort of like focused on solving a specific problem by themselves. And Netflix was able to move to a point where data scientists could meaningfully collaborate. They could replicate other data scientists' work. They could build on top of that. And all of that essentially ensured that Netflix was able to iterate on models rather quickly, test out different business hypotheses, and all of that just sort of like, gets reflected in the business outcome that gets reflected in stock prices and sort of like, just how the company is behaving economically.
So basically, as a data scientist there, I can use Metaflow to do basically complex pipelines from, the feature engineering to the kind of model training, hyperparameter tuning, and then deploy. But then in the deploy part, is there somewhat of a handoff there? And by that, what I mean, Savin, is deploy might mean you might have to do some kind of shadowing or A/B testing, or is that still my responsibility as a data scientist, or is that another team at that point?
So when it comes to sort of like, deployment, it varies from team to team, from project to project. On one side, deployment could mean that, hey, I have trained this recommendation model, and now I want to train or generate recommendations for all Netflix subscribers and dump those generated recommendations into a database, so that then every time anybody logs into netflix.com, fresh set of recommendations are available, right? So that's like one end. Then on the other end, we could sort of like have scenarios where, people have internal applications which are being powered by these machine learning models. Let's say, like Netflix wants to figure out like, okay, what is the best place to shoot a particular TV show? And that application is just recommending that. Of course, the QPS or the SLA associated with that sort of like model deployment process is rather loose compared to, say, what we would expect from the recommendation side. And then, so depending on sort of like the business context, you may sort of like, in many senses have a dedicated engineering team being mindful of like, how a model gets deployed. Case in point, our recommendation system. In many other scenarios, you could sort of like have data scientists being responsible for sort of like the end-to-end deployment. Many sort of like, internal business applications were of that nature.
So as far as the UX, for Metaflow, is it only notebooks?
So Metaflow is a Python library and as well as an R package. Okay. Which means that, if you want to sort of like use notebooks to write your Metaflow code, you can use a notebook. If you want to use your favorite IDE, if you prefer Vim, Emacs, whatever, you can use to essentially get started with Metaflow.
And so inside Netflix, you have this variety of
exactly.
users.
I mean, so Netflix is sort of like, it's sort of like a great proponent of freedom and responsibility. And when it comes to sort of like, personal choices of IDE, they highly impact productivity. So I don't think it's sort of like, fair to mandate that everybody needs to use a specific IDE when it can be sort of like, so critical in terms of how your day-to-day on-the-job performance goes.
But if you use a vendor, then you're kind of stuck with a vendor's IDE, right?
Exactly.
So what about the libraries that the data scientists love?
So, for us, we had people who used like TensorFlow, PyTorch, Scikit-learn was like, super popular. We had data scientists who would prefer to write their own algorithms as well. People using all sorts of like esoteric Python libraries as well as R packages. And we had to support everything that was available as well as, like anything bleeding edge that showed up.
Yeah, and these days that might mean large language models, computer vision, right?
So. Exactly. Yeah. So for us, that was the goal. That okay, like can we sort of like remain rather unopinionated about these libraries and sort of like just provide a way that okay, like let's say if I'm a data scientist and within my workflow, I need to sort of like train two models with say one trained with TensorFlow, the other trained with just for the sake of this conversation with PyTorch. How can I very cleanly specify that and train my models without sort of like figuring out like, oh my gosh, what exactly is Docker and how do I create these isolated execution environments? How do I even go about installing PyTorch on top of a GPU in a remote instance? So these are the problems that cause a data scientist to spend a lot of time sort of like not focused on data science problems. And that was indeed our goal, that okay, can we sort of like just chip away at many of these problems and sort of like build a product around it.
So what about Savin, experiment management, dependency management, those kinds of things? Is that core to Metaflow, or is Metaflow just integrating other solutions?
No. So like when it comes to, for example, experimentation management, that's sort of like very core and critical to Metaflow. So any workflow that gets executed through Metaflow, all the intermediate state, the execution history is permanently captured, and you can go back in time and you can also replay the events. So, let's say if you are a data scientist at Netflix and you wrote a workflow through Metaflow and you executed that workflow, say a year back, then I can come in and I can be like, hey, I actually want access to Ben's execution and I want to re-execute that and actually reliably reproduce the exact same result so that then I can build on top of that. So for us, experimentation management, dependency management, as well as the core concept of reproducibility, all of these are very tightly interlinked. And
but you folks wrote your own. You didn't use MLflow or anything like that.
No. I mean, of course, when we were starting in 2017, the state of the world looked very different. MLflow as a project was just getting started at that point as well. And for us, the kind of requirements that we had, like, many of the design decisions that we made were also very different than MLflow. We wanted to make sure that, like all the logs, all the intermediate variables, everything is captured by default so that you have complete replication of the internal state of the pipeline at any point. And the user doesn't have to worry about like, okay, what are all the things that I should be concerned about? Because when things fail, it's very common for people to be like, oh my gosh, like if only I had added this extra print statement, or if I was capturing this additional.
Yeah, because in ML, when things go wrong, usually it's some pipeline.
Exactly. And for us, it was more like, like if you look at like data storage costs, right? They are trending downwards. It's like really cheap to compress a lot of data and just like store it in perpetuity so that you can go back and refer those things. And it also aids in sort of like building more trust in your pipeline. There have
What
been
about
many.
what about data version control and feature stores? Is that are those part of Metaflow?
Yeah, so we version everything by default. Every single time you execute anything, every single thing sort of like, gets versioned. We don't rely on Git or any sort of like explicit indication by the user. So everything is implicit. And then feature stores are sort of like, a rather interesting topic in many ways, because like Netflix has invested in feature stores in the past as well. And there has always been sort of like this question that, okay, like what does a feature store actually mean? One sort of like school of thought is that, okay, it's sort of like a dual write database where you are able to sort of like access features for batch pipelines as well as access features when you're doing any sort of like online scoring. And in that particular sense, in that particular scenario, your access patterns, either in sort of like the offline universe or in the online universe, they dictate the nature of like, the databases that you would want to use and so on and so forth. And many times they become sort of like highly bespoke systems. And then, of course, there's another thing that, okay, what exactly is a feature? Is it actual data, or is it some sort of like, feature encoder? Can you think about like feature stores as a library, or does it actually have to be data assets or something in between? So for us,
there's the production side of feature stores as well, right? For inference.
Exactly. And then there's sort of like the production side as well, which is essentially the online use case, right? And of course, if let's say I'm building an application that sees like, 1 million QPS and has like, really strict uptime latencies, then the production aspect would be very different than, let's say, like if I have something that sees, say, like 100 QPS or something, and, like even if that service goes down, then I'm more or less still insulated from any financial impact. So there are like more of those business nuances that come in when it comes to the proper architecture of a feature store, and that was my experience as well. That when it comes to, say, like our efforts around Netflix recommendation stack, we essentially have this library called Algo Commons, which is essentially kind of like a feature store as a library in some sense that you can imagine, and that worked out really well. For that sort of like universe of problem where we had a rather large team of researchers focused on one specific problem of recommendations, and they needed to meaningfully collaborate. But then if you sort of like step out of that universe, and if you look at sort of like long tail of machine learning applications, then the argument around like, different data scientists wanting to share different features, that may not be really as relevant, and there could be sort of like much more cheaper ways to achieve that without sort of like investing in a full-blown feature store.
So Metaflow is technically open source. It's on GitHub. Yes. So we've talked a lot about Metaflow in the context of Netflix. Mm-hmm. So what is Metaflow outside of Netflix? So who are there users or contributors outside of Netflix? Well, yeah. Obviously you are now. You're outside of Netflix.
Yes, indeed. So 2019 reInvent was when we decided to open source Metaflow. So this was part of the keynote announcement at that event. And ever since then, we have seen many companies adopt Metaflow in its entirety. So, like on one end of the spectrum, you can think about like, many tech forward companies like, 23andMe, Realtor.com, Zillow's, of the universe who are sort of like moving to Metaflow, big banks, financial institutions, insurance firms, sports teams doing sort of like Moneyball style analysis, healthcare firms. I guess like, one of the biggest power utility generator in Europe is all in on Metaflow. So we have seen sort of like very broad adoption so far from a variety of different industries.
How about contributors?
In terms of contributors, most of the contributors are still from Netflix, as well as Outerbounds, which is the startup that I've started around Metaflow. For us, the pitch when we open sourced Metaflow was all around sort of like, keeping our data scientists front, right, and center. So in that manner, most of our contributors are also from companies that have adopted Metaflow. So that's sort of like, largely our contributor base so far.
So how much, so people who use Metaflow, when they're still doing a lot of data wrangling and data processing, is that already part of Metaflow?
Yeah, so within Metaflow, we don't really sort of like have any specific recommendation for like, okay, what kind of code is it that you're running? And at the very conceptual level, if you think about a machine learning pipeline, right, like it sort of like starts off with like, you need to read data from a certain source, you need to process that data, then you need to train a model, then maybe you need to stuff that model somewhere, right, deploy that model. Then there are many different areas where you need to sort of like optimize. The first one is that, okay, data movement. When I'm reading this data from my data store, how can I actually optimize that data movement? Do I rely on, techniques like Spark and Presto and like other analytic engines, which are built more for the reporting use cases? Most machine learning researchers, they just want to sort of like get access to the entirety of the data set and then use tools like Pandas and NumPy to process their data. Can we sort of like optimize that? Now, when you're sort of like doing data munging at such scale, it's very likely that, your laptop may not sort of like, be foolproof. And at that point, you would wish that, okay, like, can I just get, like a terabyte RAM on my laptop so that I don't have to think about like, even doing any distributed data processing. And for us, that's the key thing that, okay, can we sort of like allow user to just like write normal Python code, and then they can just annotate that, okay, these particular snippets of my code need to execute on an instance with say a terabyte of RAM. We'll execute that code, bring back all the logs, all the results. And then let's say, they have sort of like generated these features and now they want to train a model.
A single server kind of.
Single server, but then given that, for example, we are following this workflow paradigm, you could have one step that can run on a single server with a terabyte of RAM. The next step, which is training a model, could run on an instance that has, say, a bunch of GPUs. The third step, which is just sort of like dumping the model somewhere, that could run on a cheapest instance possible. But then the question is, how do you sort of like move data between instances so that people don't have to worry about that? How do you take care of fault tolerance? How do you take care of interaction with the cloud?
We need Metaflow to talk to Ray.
Yeah, exactly. If you think about like, Ray is sort of like a really good compute platform. So theoretically, you can essentially use Metaflow to orchestrate a whole bunch of different Ray workflows and sort of like talk to your data store.
Or honestly, the end user may not even know that Ray is involved.
They may not even know that, like it's Ray running underneath. Yeah, exactly.
Yeah. That's the ideal. That's the ideal scenario, right?
Yeah, exactly. Or if you say, like, for example, let's say with Metaflow, you want to do hyperparameter optimization, and we can just like farm out that job to one of the Ray libraries, and then we can just collect the result and move forward the job. So they are sort of like, for us, the goal is that, we are not sort of like trying to reinvent the wheel when it comes to data platforms, thanks to sort of like, companies like Snowflake, Databricks, numerous innovations in the open source community. That stack is maturing and we want to rely on that stack. Organizations have already invested in that. Then when it comes to the compute layer, advances in Kubernetes, projects like Ray, Dask, many others, they're also sort of like really hardening that particular layer. You can think about then, like workflow orchestrators with Airflow 2.0, Argo, step functions, Flight, many great projects.
Prefect, Temporal,
Daxter. Then, you can think about like, ways to deploy a model, right? Like OctoML, Seldon, ways to monitor a model like Arise, Truera, Fiddler. Now the goal is that, okay, as an end user, as a data scientist, how do you sort of like move across these different layers of the stack? And how do you sort of like also extract maximum value out of each of these different components of the stack? And that's where sort of like, Metaflow comes in as sort of like the operating system of sorts when it comes to sort of like a machine learning platform.
So at some point, you and your other Metaflow collaborators decided to start a company, which you can't really talk about yet, but at a high level, what is the thesis behind the company, if you're comfortable talking?
Yeah, for sure. Like when we open sourced Metaflow in 2019, given sort of like, the great reception shown by the community to the project and the massive adoption, we clearly saw that, there's a compelling business opportunity. Organizations are investing more and more into machine learning. Of course, COVID-led digitization just accelerated everything. So we are definitely at a spot where the appetite to invest in machine learning is rather high, but then organizations are essentially getting bottlenecked on two fronts. One is availability of data scientists, enough skilled data scientists, and then data scientists just not being productive enough because sort of like the tooling sprawl.
More importantly, availability of platform and data engineers to make sure the data scientists are doing something.
Exactly. And that's essentially, the area that we want to operate in. Like we see ourselves as sort of like productivity boosters for these organizations, because ultimately at the end of the day, if you look at it, right, like machine learning is a very iterative task. You cannot sort of like, come up with the best performing model at your first shot. So it's really important to sort of like, if you're maximizing business output, that you're able to iterate fast. That's when you see the real fruits of machine learning. And that's the thing that we are sort of like, set out to optimize for. And Metaflow is sort of like a great UX, a great sort of like, proof of concept in some sense, in terms of the capabilities that Outerbounds can offer. And now we can essentially offer a full-fledged platform that can sort of like, can be composed of best-in-class tools, and make sure that, if let's say you are an organization and let's say, like you are responsible for figuring out like, okay, how your drones need to sort of like, be autonomous and like in-flight planning and everything. So you are sort of like knee deep into computer vision. Then with Outerbounds built around Metaflow, you can essentially get a best-in-class ML platform. Or if let's say, you are one of the biggest retailer in the world and you want to do lifetime valuation of your customers, then Outerbounds can help you in that as well.
So when people who are behind an open source projects do a startup, the first question is the startup based on the open source project? Or, you know what I mean? So is it going to be like one of these open core companies or managed service version of the open source project? It sounds like it's going to be basically more than that. In many ways, it's probably a more polished cloud version of what Netflix people are using.
Exactly. I mean, if you look at Netflix,
but with that said, are you folks going to start with Metaflow?
Yes. And just to sort of like add more color, right? Like at Netflix, data scientists were successful not because my team existed, but also because there were really excellent teams that were provisioning, excellent data platform, compute platform, observability systems and all. And many organizations, they have incredible appetite outside of Netflix to sort of like, adopt those best in breed tools. And that's the compelling business opportunity for us. That can we also sort of like, not just be the ML infrastructure team that we were at Netflix, but also many of those other platform teams, and then provide a cohesive end user experience.
So, by the way, Savin, you used the phrase earlier, modern data platform, which to our listeners is really, most people use that phrase to refer to cloud data warehouses and cloud lake houses. So this would be like Databricks, Snowflake, Redshift, BigQuery, Synapse, and so on, right? What's interesting about these modern data platforms, particularly the lake houses, because they can support unstructured and semi-structured data for ML and open file formats like Parquet, is that now it seems like there's a virtuous cycle where you have these modern data platforms. They have a lot of users, but because they have a lot of users, a lot of startups, including yourself, target users of modern data platforms. So therefore, they become better. They get more users. Their ecosystem, So there's a virtuous cycle.
Yep.
So because you use the phrase modern data platform, so aspirationally, I assume that you are going to target users of these modern data platforms as well.
Yes, exactly. I mean, like the way I sort of like look at the situation is that, like to sort of like get gains out of machine learning, you need to have made investments in a great data platform, in a great data universe, and like good data quality and like good data governance. That becomes sort of like key. And for us as sort of like a startup that's just like starting out, it makes sense for us to sort of like target customers, go after customers who are very heavily data conscious, who know that they need to make investments in the data stack and have already made those investments and are now looking forward that, okay, what's next? how can we sort of like, now that we have all of these data assets, how can we actually ensure that these data assets are not just sort of like being used for reporting purposes, but can also be used for sort of like, predictive analysis and supercharge our business. And so that's sort of like, our target audience at this point.
And so Outerbounds is going to be cloud native, right? So cloud first, cloud only, probably.
So I mean, Netflix is an AWS shop from the very beginning of sort of like, its streaming journey, and so Metaflow was born in the cloud, and that also sort of like, in many ways distinguishes us from many other sort of like competing tools that were built in the on-prem era and then were repurposed for the cloud era. So from an architectural standpoint, we are able to sort of like leverage the seemingly infinite scalability characteristics and much better affordances that the cloud offers.
So one trend that I'm paying more attention to, I don't know if you're noticing this as well, Savin, is traditionally when people talk about low code and no code, it's actually other areas of software. So for example, for web development, you can easily now stand up a website, let's say with WordPress, with no coding at all. And then if you want to add levels of sophistication, WordPress has this massive ecosystem of plugins. You can add payments, forms, and so on and so forth. I'm noticing a slowly growing number of low-code and no-code tools in the data and ML space. So this might include data integration, data management. I mean, you can consider Airtable as some kind of data management tool. Definitely for data science and ML. So most of what we've talked about assumes that someone is coding in Python and R. So how are you guys thinking through this other universe of users who might be analysts, domain experts, but maybe non-coders?
Yeah. I mean, the way I sort of like look at this ecosystem is that, there's place for both. Of course, like if let's say I am setting up a personal blog site, I would sort of like, just sign up for like something like Kinsta or something and sort of like set up a website. Versus if let's say, I'm Amazon.com or Google.com, I'll have sort of like a massive team focused on sort of like optimizing even the last pixels available on my web page. And it's the same in the machine learning universe as well. Let's say if there's sort of like a fledgling startup that has just sort of like started out, maybe it's sort of like, not the best use of their resources to invest in the very best recommendation model or a click-through model on day one, and they can easily buy something off the shelf or use a low-code tool. But then on the other extreme, if you think about a company like 23andMe, right, they have access to sort of like, a lot of genomic data. They are processing, they are running like really compute intensive algorithms on top of the data corpus that they have, not just to sort of like inform people about their health, but also to do first rate research in sort of like, what are like the best treatments for cancer and other diseases. And this kind of requirements around like, the bespoke work that's needed, that's placed in organizations of that caliber are very different. I don't feel that, low code or no code solutions can sort of like cater to that kind of audience. And those are the kind of audiences that Metaflow was sort of like built for. So like another sort of like thesis is that many of these organizations, when they have realized that, yes, machine learning can be sort of like a tangible business advantage, then they have shown the appetite to invest in really first rate ML talent. And that sort of like also means that they also have a strong willingness to pay for ML tooling as well. And they've seen sort of like the value. And for us as a startup, that sort of like sounds like sort of like a easier or like, the most natural area to target.
But on paper, I mean, you are basically, I mean, the coding is in many ways like just a UX. So if your platform works for that UX, it could definitely take a user GUI and even hide the coding,
Yes. Theoretically, yes, it can. It's all about like, what do we focus on right now?
Yeah, of course. Yeah, of course. You got to get that critical audience down first, right? So nail down that critical audience, right?
Yes.
So speaking of which, so what's, I hate to put you on the spot, but what's the timeline? When is the reveal?
I mean, we are already sort of like, we do have companies using Metaflow, and we are working with like many companies already. So there isn't sort of like any set.
But that's more of a services kind of thing, right? So
not really a service kind of a thing. Like
so
ultimately, we are sort of like building a product, offering a product.
so when you say working with, these are basically early design partners.
Early design partners, early customers that we are sort of like working with, finalizing sort of like what our pitch should be, and like what is sort of like a compelling posture for us to take. So we don't really have any sort of like specific timeline. I think like we had the luxury of bringing on board investors who are very patient, and like if you are building sort of like things earnestly, that also sort of like takes a little bit of a time. Hopefully sometime this year we should be able to sort of like more publicly share like what does the Outerbounds platform look, and how is it sort of like meaningfully distinct from Metaflow that many people are not familiar with.
So without naming names, so the design partners, are they a mix of industries?
Yes.
Okay. Yeah. So not just tech.
Not just tech.
Good. Yeah. Tech is not representative of the of the people who ultimately might pay for Outerbounds, right? So
yep.
Yeah. Tech people are early adopters, but they may not pay for anything, man. So.
Yeah. I mean, like goes both ways.
Yeah.
I mean, if you build something that is like fairly compelling, fairly unique from what already exists in the industry, then I have definitely seen sort of like incredible willingness to pay from companies that I would have traditionally been like like they would much rather build something in house.
Yeah. Databricks will attest to that.
Yeah. Exactly.
So I'm assuming you're hiring.
Yes.
So what are the most critical positions? First of all, are you open to remote people for our listeners?
Yes, we are definitely open to remote people. We already sort of like have like half of our team is remote. So we have folks all over United States, even outside of United States as well. And right now, my personal focus is to bring on board great engineers, people who either have sort of like worked at the intersection of ML and infrastructure, or they have interest to sort of like build up their expertise. So if that sounds like you, please reach out to me.
But generally they don't have to be in the Bay Area, but if they are in the Bay Area, is there an office?
Yes. So right now I'm actually sitting in our offices. So we are located in San Francisco. So we do have a physical presence, but it's optional if you want to sort of like come in and hang out with the team. Of course, like when it comes to context sharing, being present physically, that sort of like always helps. But then given the nature of our work, given sort of like the practical realities as well, I think now we are all used to working remotely. So location is not at all a concern for us.
And with that, thank you, Savin.
Thank you. Thanks, man.